All right, Mathletes, here's another one. They're asking us to use the difference quotient formula again, and we're given a point, x equals a. This time, they do tell us to find the definition of the derivative. We're actually trying to find the equation of the tangent line, but remember that the derivative is equal to the slope of the tangent line, right? And so when we find the derivative, we're going to also find the slope of the tangent line. And then from there, we'll have everything we need to, when we get to that point, we'll have found everything we need to plug it into the tangent line, okay? So these are the formulas that we'll need. All right, so the difference quotient formula is this one right here. Remember, it's basically the secant line formula with a limit attached to it. So we go from basically average or average rate of change to instantaneous rate of change, right? We go from secant line slope to tangent line slope, right? When we add the limit, we can do it at a point, right? Because we get super, super close to that stationary point. And then the other formula we need is the point slope form. And so when we find the derivative, we'll find m. We're given x1, which is the a value, right? In this case, it's -2. And then we'll find y1 in a minute, which is going to be f of a. Okay, so this is f of a, this is going to be a, and this is m10. Okay, so by finding this, we'll have found all these other things, right? A we're given, but m10 and f of a we'll find along the way. All right, so I'm going to plug in -2 in all these places where a is in the formula. All right, so plug in -2 in all those places. Now I need to find f of -2, right? So notice how this is y instead of f of x, but remember y and f of x, you can, y equals f of x. So no worries there, you can find that. So f of -2, or you can call it y of -2 if you really want to, but we're going to plug -2 in for x, and so that'll change all these x's to -2. And now we can just operate. Don't forget to do exponents before you multiply, right? So it's going to be, this will turn to +4. So it'll be 2 times +4 plus -2 plus minus turns into a minus plus 5. And so 2 times 4 is 8 minus 2 plus 5. And so 8 minus 2 is 6 plus 5 is 11, right? And so f of -2 is 11. So we're going to put 11 in there. Okay, and then for f of x equals this whole thing, right? Or y equals f of x. So I'm going to put that whole thing into f of x, 2x squared plus x plus 5. Okay, so when I rewrite this, this is what it's going to look like. All right, so here this whole thing is f of x. Here's f of -2. -2 on the bottom, that turns into a positive, right? So I have x plus 2 there. All right, so now I just want to combine like terms. And so 5 minus 11 is -6. And so I'll get 2x squared plus x minus 6 all over x plus 2. Okay, so now if I did plug in this -2, if I directly substituted, we would have a 0 in the denominator, right? -2 plus 2 is 0. And we'd also get a 0 in the numerator. 2 times -2 squared, that comes out to 2 times 4, which is 8. Minus 2 is 6. Minus 6 is 0, right? So we'd end up with a 0 over 0 situation, which tells us that we have to algebraically manipulate this, right? And so that's what we'll do. We'll try to, in this case, since we have a polynomial over a polynomial, we'll try to factor and cancel. So this is a complex quadratic. On the actual quiz, I'll give you a simple quadratic, but just a little practice here. Remember that we can multiply a times c. So 2 times 6, we get 12. We want to find numbers we can multiply to get 12 that we can subtract to get +1, this invisible 1 here. And so those numbers would be 3 and 4, right? So you can make a list of factor pairs, 1 and 12, 2 and 6, 3 and 4. And once you get to something where the next one would be 4, it's already on this other side, that means you've exhausted all the possibilities, okay? And so this is the one that works, 3 and 4. we want to get a positive one. So our bigger number is going to have to be positive. And so the 4 will be positive. And since this one's negative, that means the signs have to be different, right? To get negative when you multiply, the signs have to be different. Negative 3 times negative 4 is negative. Will get us negative 12, okay? And so anyway, so those are numbers. Remember that what we do is we put those into parentheses here like this. So it's going to be x minus 3 and x plus 4, okay? And we know that's not going to work, right? Because x times x doesn't equal 2x squared, right? And 3 times 4 doesn't equal 6, right? So here's the key part is we take whatever that a value is and we put it underneath both of the numbers that we just found. And then you try to reduce. So 3 over 2 does not reduce. So that 2 goes to the front and the 3 stays where it is, okay? And so we end up with 2x minus 3, okay? And then for this other side, 4 over 2 does reduce, right? This reduces to 2 over 1. So the 1 will go to the front, and it can be invisible, and the 2 is going to stay, so we end up with 1x. I'm just going to write just x by itself, but there's an invisible 1 in front of it, and then plus 2, right? So that 2 stays on, this 2 on the top stays there, okay? So that's our factored version. So I'm going to rewrite this 2x minus 3 times x plus 2 all over x plus 2. And that's helpful because now the x plus 2's cancel out, which is what should happen and always will happen if you do this right with this formula. You always get the denominator or whatever's causing the 0 in the denominator to cancel out. And so now we can directly substitute, so I can reintroduce the limit. And when I plug in negative 2, I get 2 times negative 2, which will be negative 4, minus 3. So negative 4 minus 3 is negative 7, okay? So that's the value for our derivative at negative 2, which is also the value for the slope of the tangent line, right? So now I have m. Also, let me zoom out here. Also remember that this is going to be our y1, right? It's f of negative 2, but it's also our y1. Remember that this value is our x1. So we have m here, we have y1, we have x1, so we have everything we need to plug into our formula. So so what that's going to look like is y minus y1, which is 11, equals m, which is negative 7, times the quantity of x minus x1, which is that negative 2, right? Okay, and a negative negative turns into a positive, so we can change that into x plus 2. Okay, you can simplify this and turn into slope-intercept form if you want to distribute the negative 7 and add 11 to both sides, but it's okay to keep it here for full credit, okay? All right, so that's the work to find the slope of the tangent line. Remember that, or to find the equation of the tangent line, the main thing is we need the slope of the tangent line, and right, and the only way to do that is to find the derivative at that point, okay? All right,